But when they came back, I said, so were there any interesting papers? And they said, yeah, everybody seemed to like this thing on monads. I went, monad? Oh, that sounds very scary. I read Eugenio's paper, which was very straightforward. I was at Glasgow at the time. Eugenio was at Edinburgh at the time. And I got on a train and went across the country and spoke to him. And fairly quickly cottoned on that, oh, this is a useful way for structuring programs. So he'd used it for structuring denotational semantics. But denotational semantics is basically just an interpreter written in a functional language. And so the first papers I wrote were basically explaining, or one of the early papers I wrote, the first tutorial I wrote was, okay, you could use this to write a bunch of different interpreters. I just went through a bunch of concrete examples. So you want an interpreter, I picked the simplest interpreter I could, one that does division. And then I said, okay, you want to count the number of division operations. So normally you do that by incrementing something. So what's the equivalent that we're going to do here? It was passing some state around, which was the number. In this case, the state was the number of divide operations that you'd seen so far. Or what if you want to do a trace? Well, that's building up an output. So you have an output from one part and output from the other part, and you concatenate them. Or you want to give an error message when you divide by 0 rather than exploding. And so you pass it around, either, yep, this is an answer or this is an error message. And so those are the 3 concrete examples. So, each of those is easy to do. You just completely rewrite the program. And the point was, here's an easy way to do it where you don't have to completely rewrite the program.